आज का हमारा सेशन है डाटा शेयरिंग एंड साइबर सिक्योरिटी। आप लोगों ने अब तक साइबर सिक्योरिटी के बारे में कई सारे लेक्चर कंप्लीट कर लिए हैं। अब हम इसके ये सेकंड लास्ट है, इसके बाद कल आपका एक सेशन और है। डाटा शेयरिंग और साइबर सिक्योरिटी में आज हम कवर करेंगे, जिसमें सबसे पहले डाटा शेयरिंग के स्टैंडर्ड्स की बात करेंगे। About data sharing standards, common data sharing standards, key principles and challenges. Then we'll cover up the cybersecurity aspect while sharing the data. There are some core cybersecurity principles, supporting cybersecurity principles and measures to be taken care of during the data sharing activity, and regulatory and compliance requirements. There are some threats to data sharing, we will discuss that. Then there are some advanced solutions for data sharing and security. We will discuss that part also. At the last, we will discuss about the best practices for securing data during transactions. Data sharing standards facilitate interoperability and consistency across systems. So while cybersecurity ensures that the exchange is protected from threats. So those two things, when it is combined, then both of the parts becomes very sensitive, and we need to comply with the regulations to foster the trust between entities. While sending the information, the sender is ensured that the data is secure. At the receiving end also, many times we are ensuring that data is secure. But during the transaction, if any misconceptions are happening and data is being modified maliciously, then we will not be aware of the truth that data is not correct. So we need to be secure, and we need to see that both the aspects, data sharing standards, are followed and it is secure. The increasing volume of and sensitivity of data being shared, it increases the risk and the data breaches, unauthorized accesses and regulatory penalties. Effective integration of data sharing standards and cybersecurity measures creates a robust framework that not only enhances operational workflow but also safeguards against evolving threats. So these combinations will support ethical data handling and ensures business continuity and reinforce stakeholders' confidence. This is background and the introduction about the topic. So basically, we are going to cover up those two parts. One is data sharing standards, another is the security of data while transactions. There are many data sharing standards. We will follow a little of them. There are data sharing standards, interoperability standards, threat protections, and security guidelines. Common data sharing standards are XML, Extensible Markup Language, that is widely used for structured data enhancing, exchanging in business applications. Many websites are keeping XML information so that it is interoperable. Whenever you are using different language for coding, that information of XML file could be integrated with the new database, new data sharing in the Java or any other language if you are preferring. Same way, JSON is also a lightweight and human readable idea for APIs. So whenever integration between websites are there or transaction of information between multiple portals are there, then JSON is being used as a standard data sharing protocol. EDI is electronic data interchange, industry specific, commonly used in retail and logistics. This is standard followed for the shopping malls, and cards whenever you are sharing the electronic information. In that case, this format is being used for data sharing. FHIR is basically used for healthcare industries. This is fast healthcare interoperability resources, specially designed for healthcare section. These are basically the files of people who are getting treatments in hospitals. This is a standard for the healthcare section. Dublin Core, a metadata standard for cataloging resources like books and digital archives. This is also one of the standard in libraries nowadays. OData is Open Data Protocol that is streamlines querying and updating of data across multiple systems. This is one type of database protocol which handles the multiple queries at a time and across multiple systems. REST and SOAP APIs, they are essential for web-based services enabling seamless communication. So basically, apart from the EDI, FHIR, Dublin Core, and OData, remaining three, XML, JSON, and REST are SOAP APIs. They are basically used for websites and portals. However, XML is also used for multiple other purposes that we will come across. Many other industries also we find that XML data is being used. So these are some common data sharing principle standards. Now we'll come to the standards. In some standards like CSL also there. We are not discussing all those things. These are few of them we have taken for discussion. Key principles while sharing the data that are like interoperability that enables different systems to communicate and work together. So while sharing the data between systems, we should ensure that these standards which we have discussed just now and any other standard, if it is to be followed, it should have interoperability principle to be followed. Second is data integrity, ensuring the data remains accurate and unaltered during the exchange. So data whatever you have sharing from one system to other system, that is not modified during the transaction. Standardizations, while we are following uniform scheme for better compatibility as part of the standard, that is compulsory because the reading system and the sender both should be aware of the standards. Like XML file is being shared, then both the sender and receiver are aware that we have to operate and dissection of the information is to be taken care according to the standard being followed. Then there are metadata uses that leverage metadata to describe, categorize, and facilitate data discovery. Data discovery we have discussed before lecture also. That is part of data discovery while we are categorizing information based on metadata. There are some key principles and these are some common data sharing standards. Now we'll come through the challenges in data sharing to understand how the data sharing is become very difficult nowadays. And as the data size is increasing, we are continuously facing problems in sharing the information among the systems. One of them is lack of standard adoptions. What happens is normally we follow one type of standard and protocol. However, the new systems which we generated later are having some new standards and some compatibility issue also comes up. So this becomes a major challenge in case of following the protocols and standards. Data silos, organizational barriers that restrict data flow. So there are some data centers, data warehouses. They have their own protocols to restrict the data whenever data goes out of the system. And there are some regulatory compliances, navigating complex laws like GDPR and HIPAA. These are some standards which to be followed, regulatory standards to be followed by the systems which are using the data as a storage, or they are custodian of information. Many of them are becoming difficult due to government guidelines, like GDPR is government guideline for following it. Whatever is being transaction or whatever being kept in the storage has to follow the standard, so that it is standardized and the policies are easy to implement on them. Now we'll come across the data sharing difficulties as part of cybersecurity aspect. Proxies support. Proxies can provide an additional layer of security by acting as intermediary between internal and external network, inspecting and filtering information. Cybersecurity aspect while sharing the data, that means we are taking care of the cybersecurity aspect while sharing the information. So for that, these are some methods by which we can take care of the security aspect in sharing the information. Another is data network address translation. In the last lectures, we have discussed about the features of firewall, and these features are also provided by firewall. If there is no firewall, you can have another alternate method of implementing these techniques so that your data sharing is being securely implemented. Network address translation allow firewalls to hide information, internal network structure, and information about your internal IP address series, so that it is only one IP address known to public. Intrusion detection and prevention systems. Integration with IDPS can help identify and block malicious activities by monitoring and analyzing network or system events. This also we have discussed in my last lecture. I have discussed day before yesterday. Virtual private networks, VPN activities. This is for secure communication over untrusted networks, so that confidentiality and integrity of data is maintained during transit. User authentication supports for various authentication methods, including user-based authentication to control access based on user credential. So there are security aspects which to be covered. Now we will come to the basic principles of cybersecurity. I think yesterday also it was discussed. Cybersecurity aspects are dependent on three core factors. One is confidentiality, integrity, and availability. This is called CIA triad also. Confidentiality, just to revise probably the yesterday lecture. Confidentiality is ensuring that sensitive information is accessed only to authorized individuals, or implemented through encryption, access control, and securing communication protocols. So this is method of implementing the confidentiality. Integrity is ensuring that data remains accurate, complete, and unaltered during storage and transmission. This implementation is completed using techniques including checksums, hashing, and secure audit trials. Availability is ensuring system applications and data are accessible when needed. This is ensured by archiving for redundancy, disaster recovery plans, and protection against denial of service attacks, DOS attacks. So these are three basic concepts of core cybersecurity, and these basic principles of cybersecurity are also known as CIA triad. These are supporting cybersecurity principles. Supporting principles includes authentication, that means verifying the identity of users, devices, or systems before granting access. For example, passwords, biometrics, multi-factor authentications, these are part of authentication. Authorization is ensuring that users have access to resources based on their role or permission. Many times we get confused between authentication and authorization. Authentication is about the devices and users. So we can remember in that way that authentication is about devices and users. That means systems and users are kept informed about based on the role models. So role models like you are administrator, then you have a role of administrator. Now authorization comes based on roles and permissions. So password is a authentication method. Once you log into the system, you are authenticated or not, that depends on the correct password or correct biometric. Once that is done, then authorization part comes. That authorization indicates whether you as an individual are allowed to access the printer, scanner or video camera, audio device, like that. So authorization is to use. If you are authorized to use something, then it is called authorization. Right? So there is minor difference between authentication and authorization. Now we come to the third part of supporting principle, that is non-repudiation. That indicates ensuring actions or transactions cannot be denied by originator. That is, we cannot say that I have not signed a document. How it is possible? Digitally, we ensure by using the digital signature or logging the communication, then audit trials. So based on these methods, we ensure that the person who has done this activity is ensured and verifiable that the action is done by the original person only. Apart from that next is the accountability. Keeping user accountable for their actions through detailed logging and monitoring. This is accountability principle of cybersecurity. These are supporting principles. Then resilience, ability to recover and continue operations during and after the cybersecurity incident. That means the systems are resilience, they are capable of the ability to recover and continue operations during and after the cybersecurity incident. That means whenever this lecture is being transmitted and you people are seeing it at your place, the attacks are being continuously executed at the devices of our organization, but they are being resilient and they are maintained so that cybersecurity principles are being implemented and service operations are continued. Next is the privacy, protecting personal and sensitive information from unauthorized access and misuse. So these are additional or supporting cybersecurity principles to be taken care of while using data. Next is encryption. Encryption at transit and encryption at rest. These two types of encryption are there. There are many variants of encryptions during transit, but most of the websites are using TLS SSL protocol for securing transmission on websites. Same way you can utilize in other type of protocols while sending or receiving the data. At rest, when you are storing the information, we can encrypt using various other methods like password or WinZip or RAR compressed files. In that methods also we implement two methods at a time. One is encryption, another is compression. So here encryption part is transit and at rest. Next cybersecurity measure is access control. Access control is to implement role-based access control or attribute-based access control or use multi-factor authentication for added security. Data masking and anonymization, masking sensitive information, data fields to minimize exposure risk. That is so that publicly information available, but there is important information is masked, like Aadhaar card is being masked nowadays. So instead of full numbers, only few numbers of the Aadhaar card is shown. That is cybersecurity measure while data sharing. Removing personal identification numbers or any information that could identify a person individually and it is not necessary to keep in the sharing list. Such information is being kept out or removed from the list of sharing. Secure APIs are also available that employ API gateways, input validation, and rate limitation, so that multiple demands of API transactions are limited to a number. Network security, which we have discussed last lecture also about firewalls, VPNs, and IPS. Then monitoring and logging. There are some regulatory and compliance requirements which we have just discussed about general data protection regulation that emphasize data privacy and user consent in European Union. Based on GDPR, Indian government also has made some rules, regulations which are in consideration. Soon they will be available for implementation. CCPA is for California Consumers Privacy Act that protects consumers' data rights in California. HIPAA is Health Insurance Portability and Accountability Act that ensures healthcare data security. ISO IEC 27001 International Standard for Information Security Management System. These are some of the information systems which we have considered. There are many others based on the industry and type of information, type of data. The standards are different and requirement for regulatory authorities are also different. Like medical sector, they may not be following the ISO or any other, but they have to follow the Health Insurance Portability and Accountability Act. And this also depends on country to country. Now, what are the threats for data sharing? The threats for data sharing are man-in-the-middle attack. We call it MITM attack. That is intercepting the data in transit. So while it is going from one website to other website, or your API is taking data from a service provider, in the middle itself, the data is being tapped and kept a copy of that information. That is being utilized for malicious purpose. So this is called man-in-the-middle attack. There are various methods and there are various tools for implementing that. That is software based also, and sometimes the hardware cables are also being tapped for information copying. Data breaches. Data breach indicates the unauthorized access of sensitive data. In our last lecture, we covered this topic. Phishing and social engineering, that is exploiting human errors to gain access, like your information of your name, like information about your residence, information about your city. This could be a part of your password, or this could be password of your secure information. This is probability based things, and this is being taped during the communication with the person. So using a phishing process or a social engineering process, the information is gathered from a person to gain the access of his credentials. Malware and ransomware, they are compromising systems to encrypting data for ransom. Shadow IT is employees using unauthorized tools or services to share data. Many of the working employees of an organization may be utilizing the tools for or services for sharing the data to other people. That is called shadow IT. Third-party risks are there while sharing the data with external partners or vendors. It is getting exposed through their systems. That means when you are taking in some secure information and keeping it to the third party, the third party is getting some breach and your data is getting leaked through the third party. So this is called third party risks. And cross-border data sharing risks are transferring data across countries with differing regulations or inadequate protections. So if your data is being shared over the internet and data is protected, but same data is some servers of that service provider is kept in some other country where the adequate protections are not implemented or not bounded by the regulatory authorities. In that case, data leaked from that country will come under this type of risk. And last is the insider threats. The employees, contractors, or trusted partners deliberately or unintentionally misuse the data. Many times while sharing information or discussing some unofficial discussions also, we use some examples of office informations that leads us to share the information of company or secure information about individuals, which is getting misused by those people or later some other person. Such type of threats are there in the data sharing. So these threats are getting categorized based on the CIA triad, which we have earlier discussed. So threats comes under confidentiality are breaches where sensitive data is accessed or exposed without authorization. So what are the type of threats will come under confidentiality breach? Unauthorized access, that is exploiting weak access controls, stolen credentials, passwords. So this is breach to the threat to the confidentiality. Another type of data breach is hacker stealing and leaking in confidential information. That type of breach is also part of threat to confidentiality. Man in the middle attack, MITM, we discussed, intercepting data during transmission. That is also threat to confidentiality. Phishing or social engineering type of attack is also threat to the confidentiality. Third party risks, which we just now discussed, for example, and that example shows that this information is getting leaked and that is threat to the confidentiality. Cross-border data sharing and shadow IT also part of threat to the confidentiality. There are some threats to integrity like data tampering. So if data is altered or corrupted, leading to inaccurate or unreliable information, that comes under data tampering, malicious modification of records, malware, ransomware, that is corruption or encryption of data, lack of data integrity, that is unintentional errors or deliberate alteration of data, insider threats, employee altering or mishandling the sensitive information, and regulatory non-compliance, mishandling data in a way that violates standards, potentially leading to data inaccuracies. So these are the threats which leads to integrity violation of data. There are threats to availability like denial of service. Once attack is there, denial of service, DOS attacks are there or DDoS attack is there. In that case, your system is not available for the service which it is intended for. Ransomware also encrypts the data and data service is halted. Insider threats also lead to sabotage sometimes. And third party risk also makes outrage or breach to vendor affecting data accessibility. So these are part of threats to availability. But there are some attacks which leads to multiple, either not individually like CIA one or one by one. There are some multiple aspect of CIA being affected by those threats, like malware and ransomware impacts confidentiality, integrity, and availability. So all the three are getting compromised. Insider threats can breach confidentiality, integrity, and availability. Third party risk can compromise all three aspects depending on scenario. So we need to see whether these basic ideas of data security, which we discussed here, core cybersecurity principles, are getting distracted or compromised by many types of attacks. Sometimes they are affecting only one part, sometimes affecting all the three parts. Now we will move on about emerging solutions. Emerging solutions are privacy preserving technologies which help us for maintaining the PPT, that is privacy preserving techniques. So there are the tools and methods that protect sensitive data while enabling us to use, share, and analyze the information. One of them is encryption. That means protected data confidentiality during storage and transmission. So there are multiple type of encryptions Once we have, in the last slide we discussed about based on scenario, like it is on transit or it is on rest. But now we will discuss about how the encryptions are being implemented based on the techniques which we are using. One is symmetric data encryption, another is asymmetric, and third is hybrid. So these three are based on earlier standards, but nowadays there are new developments and homomorphic encryptions are also available. Homomorphic encryptions are basically utilized for data sharing principles and security. We will cover up a little bit about what is symmetric. Symmetric encryption is, by definition, it is using the same key for doing encryption and decryption. Common algorithms for symmetric encryption is AES, Advanced Encryption Standard, and DES, Data Encryption Standard. These are very old standards but still useful, and they are very successfully doing the encryption and decryption activities. Advantage is it is fast, suitable for large data sets, but it has issue with the key distribution because encryption and decryption keys are common. So both keys are same. Now another part is asymmetric encryption, where there is not a single key for encryption or decryption. There are key pairs for encryption and decryption. So by definition, there are pair of keys, a public key and for encryption and a private key for decryption. So it makes it further safe. Whoever is having the private key can decrypt the information, otherwise the information will be publicly available with the public key encryption, which is unreadable or ununderstandable. Common algorithm for this is RSA and ECC. It has advantage of solving the key distribution issue, while because essentially only the public key need to be shared so that everyone can encrypt the data and send. While reading the data, only private key is required. The disadvantage is it is slower than symmetric encryption, and it is more computationally intensive. More processing units are required. Now we come up to homomorphic encryption. What it is? It is an advanced encryption technique that allows computations to be performed on encrypted data without the need of decrypting it first. That means your data is encrypted and the process is happening on the encrypted data. The result of the computations are also encrypted, and then only by the it only be decrypted by the data owner, ensuring privacy throughout the process. So the data is secure at the first place and all the processing is getting completed. Result is also being keep safely there, and the user, original owner, can decrypt it later. In the encryption, the data is encrypted using homomorphic encryption schemes. Computation is operations like addition, multiplication are performed directly on the encrypted data by an external party or system without revealing the data. Decryption processes after the computation, the encrypted result can be decrypted only by the authorized party to reveal the final outcome. So this is quite different from the original standards of encryption methods, and this homomorphic encryption is being utilized for data in transit or shared data types. In this also there are three types. Basically, partial homomorphic is about only a particular, like supports only a specific set of operation like addition or multiplication on encrypted data, like RSA, AlGamL supports addition and multiplication but not both. This is called partial homomorphic encryption, PHE. So that is only one type of operation could be performed. Either you can have addition or you can have multiplication process on the encrypted data. Somewhat homomorphic, it is SHE. This supports limited number of operations, but eventually noise accumulates in the ciphertext, limiting the number of operations. So there are limited number of operations you can perform on the encrypted data. That includes addition and multiplication both, but the number of times it could be done, it is Limited. Third is the fully homomorphic encrypted FHE that supports unlimited operations on encrypted data, both addition and multiplication, making it a most versatile and powerful form of homomorphic encryption. However, it is computationally intensive. That means it needs more processing units, more processing power, and it takes accordingly consumes more time also. So these are homomorphic encryption types. Now where it is used and how the applications of homomorphic encryption is done during the cloud computing. It allows cloud providers to process encrypted data on behalf of clients without ever decrypting it, ensuring data privacy. Privacy preserving data analysis, enabling organizations to analyze sensitive data like medical, financial, while maintaining the confidentiality. Another application is securing voting system. It allows votes to be encrypted and counted securely without revealing individual voters' choice. So these are few examples, few applications. There are many more applications possible, and in future that may be utilized. What are advantages? Data privacy is first. Sensitive data can be processed without exposing it to the entity performing the computation. So the processing is done by the third party on cloud or on premises, but it is not known that what information is being processed. Regulatory compliances, it helps organizations to comply with privacy regulations like GDPR and HIPAA by keeping data encryptions encrypted. Security protects against insider threats and unauthorized access, as the data is never decrypted during the processing. So these are advantages of using the homomorphic encryption. In that there are challenges. One is performance overhead. Obviously, when we are performing on encrypted data, there is number of overheads to be taken care. Temporary storage has to be sufficiently big enough. And then complex and requires specialized knowledge, because the advanced techniques and tools to be utilized for this purpose. Limited adoptions. Due to performance limitations, homomorphic encryption is not yet widely adopted in real time or large scale applications. So these, as I discussed earlier, it is a new and upcoming encryption standard for data sharing processes. Apart from this, there are many other techniques which are emerging solutions for privacy preserving technologies. Differential privacy, that adds statistical noise to the data to protect individual identities while preserving overall trends. This is being utilized for public data release, analytics, and machine learning models. Examples are Apple and Google, who are utilizing anonymity, applying anonymity in the data while collecting it. What we are discussing, we are just covering up once again from the blast. Here we have started emerging solutions. In that, first emerging solution was encryption, and then we discussed about the encryptions which are older or being utilized since many years. Then we discussed about the homomorphic encryption, which is comparatively new and more applicable to the data sharing aspect. Now we covered up the homomorphic solution till here, and now we are covering the other aspects which are emerging solutions for privacy preservations. In short, there are many, but we will just cover up little bit some of them and putting the key aspects of that. So differential privacy we have just discussed. In that, purpose is to safeguard the data and keep the overall trend going. However, the information is anonymized by using noise. So we are putting statistical noise in the data so that it is not known or not clearly identifiable. Third thing is zero knowledge proofs. That is, what is the purpose? It proves knowledge of data without revealing the data itself. So what is use case of that? It is verifying identity. How to verify identity? To confirm your Aadhaar card. Like that, information is being securing authentications. So this information is kept as a encoded information, but it is used for verifying whether the person is correct. Example is cryptographic protocols in blockchains. Fourth one is securing multi-party computation, SMPC. It allows multiple parties to jointly compute a result without revealing the private inputs. So that is use case of collaborative analysis and privacy preserving AI. In this method also being utilized for sharing health data between hospitals without exposing individual records. So these are the emerging solutions for data sharing. And fifth one is federated learning, that is enabling and training machine learning models on decentralized data without centralizing it. It is utilized for personal devices, smartphones, to train model locally to preserve privacy. Google's Gboard for this is an example of that. This you are using Google Gboards are being utilized almost all of you. You may not be aware that this is a privacy preserving technology. Like whatever you typed little bit back, when you are continuously chatting, you would have seen this. That same word comes after a word whenever you are typing on this. Like for example, if you are typing that what is the my name is this, or what is my name, like this information, if you are typing continuously on your phone, next time whenever you type what, it will automatically suggest you is. That is the learning algorithm of Google in your smartphones. Apart from that, there are anonymization and pseudonymization. Anonymity is irreversible, removes identification information, and pseudonymization is replaces sensitive data with pseudonames but allow re-identification under certain conditions. So use case of that is data sharing for research and analytics. Another solution is tokenization, that replaces sensitive data, credit card numbers, with non-sensitive tokens. So example of that is using PCI DSS compliance systems for payment. Like whenever you are paying on the shopping mall or any other shop by using your credit card, in that case your credit card information is being read, but it is stored as a token and then payment is done based on that token. It is retrackable, but it is not easily identifiable. Next is trusted execution environment, TEE. Purpose of that is hardware based secure environments that process data while keeping it isolated and protected from external threats. Use case is secure cloud computing for IoT devices. For example, Intel's SGX is one of the TTE. Data masking we have already discussed. The purpose is to hide sensitive data using techniques like encryption, hashing, obfuscation, or non-production environments. In use case, software testing, developments, and data sharing is the example of data masking. We have discussed a little bit about blockchain. In detail, we will come out of for blockchain. What is blockchain? Blockchain enhances the data security by offering a decentralized tamper-resistant ledger that ensures integrity and transparency. In this, each transaction is encrypted and linked to previous one using cryptographic hashing methods for unauthorized alteration prevention. The distributed nature of blockchain eliminates a single point of failure, reducing risk of data breaches. Additionally, it consensus mechanism validates transactions, preventing fraud and unauthorized accesses. So blockchains are utilized for continuity and removing the possibility of tampering the information. Blockchain can also provide granular access controls, ensuring data confidentiality while maintaining traceability. So data is traceable, confidentiality is maintained. However, data is tamper-proof. These features make it an effective solution for protecting sensitive data, ensuring compliance, and fostering trust in data sharing and storage systems. So there are steps while creating a chain in the blockchain system. In that, first we will have a transaction initiation, then transaction is generated and block is generated using the previous information or hashing information of the previous data. Apart from the previous data or hash of previous in a chain, we have additional information randomly generated to create the new chain in the block. And this is being continued for many times so that decryption is very difficult, and even after decryption it is not easy to modify the information. So this is about blockchain. Now we have come towards the completion of this. Now best practices for securing the data sharing, what we come across till now. First is regular updates and patching. So known vulnerability are regularly maintained and patched so that new attacks could be avoided in the system. Cybersecurity awareness trainings, they are as part of lifestyle. We have to maintain that regular training in the employees and people who are utilizing the data. That education should be pertinent, sent to information staff about threats and safe practices at regular intervals. Risk assessment and audits, regularly evaluate systems and mitigate the risks. Risk assessment and audits are compulsory, and every regular interval they should be maintained, and log of information, those whatever audits we found things and what are the things are continued, what are them are stored back. That information should also be kept so that later we are aware that how we have completed or restored the faulty system. And last is incident response plans. Prepare for swift action in case of breach or attacks. So the plan of your system should be ready and tested properly beforehand, before saying that we are incident response ready. So these are 4 basic and minimum principles to be maintained for securing the data at your end. Zero trust architecture is one of the key concepts while safeguarding your systems. It is a cybersecurity framework that operates on the principle of never trust, always verify. Unlike traditional security models that assumes trust for users and devices within the network perimeters, ZTA requires strict identification of people or users which are using the information, regardless of location, whether they are inside or outside of the network. ZTA incorporates key components such as identity and access management, multi-factor authentication, and least privilege access, and continuous monitoring. So this architecture is best fit for safeguarding our structures internally, our organizations. Every access request is evaluated in real time based on various factors like user identity, device health, location, and behavior patterns. By segmenting resources and enforcing granular access control, ZTA minimizes the attack surfaces and limits potential damages from breaches. In this type of architecture, if one machine is compromised, that compromised machine will be isolated and kept separate from the network so that this malicious virus or attack could not spread further in the organization. It is particularly effective in addressing modern threats like insider attacks and advanced persistent threats APTs, making it essential for securing hybrid work environments, cloud-based services, and sensitive data. So this is one of the key aspects for safeguarding organizational level. In conclusion, we can say that adhering to the robust data sharing standards and implementing cybersecurity measures ensure secure and efficient data exchange. Organizations must prioritize compliance, stay updated on emerging threats, and adopt innovative solutions to foster trust and reliability. So now we have come to the end. We will have a 5 minutes break and your questions, queries could be answered after that. Thank you. Thank you, everyone. अभी हम आपके क्वेश्चंस के बारे में बात कर लेते हैं थोड़ा सा। आप में से आशुतोष कुमार दीक्षित, हाउ कैन वी यूज विंडोज एंड लाइनक्स ऑन द सेम desktop? Same desktop means same PC. Okay, you can use both of them using virtual machines, VMware, and many other such tools are there which you can utilize for running multiple systems. You can have multiple Windows computers at operating system running on the same physical machine, or Linux on the same physical machines. There are many other methods also, but best is to use VM tools. One last question: difference between SSD and HDD. HDD is hard disk drive. It uses magnetic drive, magnetic platters to store the information in 0 and 1. That means the binaries are stored on the magnetic magnetic disk, which is multiple magnetic disks are there in the hard disk drive. So hard disk drive is HDD, which were used earlier. Nowadays, recent developments are solid state drives, that is called SSD. So solid state drives are utilizing the electronic method of storing bits, that is faster, and as compared to HDD it is very fast. That is advantage, but it has disadvantage of failures cases. You cannot repair that part. So multiple SSDs are being used for backup. Shailendra Kumar, how can we apply data sharing standard, especially REST and SOAP APIs? Can we apply them in my own created online tools? Okay. SOAP and REST APIs, they are used for taking data. For example, you want to take information from a website which are hosting the population information, and from that population information, for a city population, you want to take that city information in your website, your portal. In that case, what you will do is you will create a API, and that API will communicate with the API service of that website from which you want to take information, and that API which you have created will talk to that API which is providing you the data from that website, and this communication will provide you the information about population of particular city which you are requiring. So such information is you are getting from another system or website using the API. In that REST feature or SOAP feature, whatever you are using, that method will utilize the standards. So obviously you can utilize that. What is Shri Vatsan? What is JSON? We have explained just now. JSON is a standard for data sharing or keeping the information in a file. So JSON file is called, that file is called JSON file. That is storing information in a particular format so that it is readable to multiple type, that is as a standard, JSON standard. So many of the tools which are ready to run based on JSON information. So if your information is kept as a JSON format, then you can directly run your program on that information to calculate or do whatever analysis you want. Even for presentation purpose also you can utilize that information. These are only few questions in the portal. So we will take some questions from the YouTube also. Kajal, can we use our computer without any antivirus for study purpose in Windows 11 safely, or it is necessary to install antivirus. Installing antivirus and updating Windows. These two parts are generally recommended, because once it is found that Windows is vulnerable or easy to hack due to some vulnerability in the operating system, then they will send you the patch. So to update that, you need the license of Windows. So better to utilize always the licensed operating systems. And antivirus part, if you are using any antivirus, then it is better. If still you are not able to utilize the antivirus due to any other reason, then you can enable your defense system in the Windows Defender. So Windows Defender, if you enable, the basic minimum requirement of safeguarding your system will be fulfilled. However, it is recommended to utilize. Okay, there are many questions in YouTube. Okay, Aparna Pandey, federal learning is good feature of Google Gboard. Yes, it is good for user accessibility purpose, and it gives you easy typing. You can directly type, select the text which is suggested by Gboard based on the federal learning of Gboard. So that way it is good, but for long term it is analyzing your behavior, and that they may be indirectly utilizing that information for their purpose. But once we are in the scenario of social media and utilizing electronic gadgets, we have no other option to go away from that. So it's okay, it's not bad. Which OS is better? Security purpose Linux is better. Linux variants are also better as compared to Windows. Let's see some queries from the top. How to attempt quiz? No quiz is available on dashboard. Yes, quiz will be available after tomorrow. So once all questions are ready, we will make it ready. This is from Shramanti Chakravarti. Yesterday notes not visible on dashboard, and explain me exam schedule. Exam schedule is already told, Uday Patil. Visibility, okay, notes are not visible. We will make it visible by today or tomorrow. Maybe probably today itself it will be available. Okay, most of the questions are answered here also. So Amit Maurya, I got my approval today for this course. How will I watch and mark attendance in the previous sessions? You will have all the sessions in your LMS portal, the Learning Management e-class portal. So you log in there. Once you log in, you will have old sessions in video recorded sessions. So you complete by watching them, and then exam will be there. So complete the exam. Okay, so we will close for now. Thank you everyone for having this session, and tomorrow is our last session.